Before we start laying the loop, I'm just going to run you quickly through the tools and equipment that we're going to be using today. Here we've got a DLR5 kit which consists of two identical loop amplifiers fixed in here. Normally you would lay a loop with cable, but obviously we're laying it on the floor and we don't want it visible under the carpet. So we're using this copper flat tape. This is flat 2005. To seal that down onto the floor, we're also going to be using this warning tape which we'll put over the top and hopefully should stop any carpet fitters from cutting through it. And then at the end of the system we're going to be testing it. We'll be using a signal generator to put the tones in that we'll need to do the testing. And then we're going to go out into the loop system with the FOS meter, which will test for field strength and frequency response. Looking at the back of the DLR, it's very simple to see how it's connected. Obviously one of the loops, the first loop, possibly the green loop, is going to be attached to loop 1 here. It's obviously a complete turn of flat cable. And then we've got loop 2 which is going on here. These are both tied into the two amplifiers that you could see in the front. We've then got a microphone input that we can put in. We've also got a line level input that we can use for background music or for a PA system to be wired in or radio mic system. We've also going to be putting the test equipment in through that plate as well. And then finally we've got the APPS, which is a phase shifter plate, which takes any of the signals input through the outreach plates and splits it 90 degrees and puts it into the amplifier. So everything you need to do the phased array system is contained in this one rack. Okay, before we start laying the loop, it's important to evaluate how suitable the floor is. And sometimes you won't get a floor as clean as this. Sometimes it'll be quite dirty and there'll be bits, so you need to sweep it. And maybe you could consider using a roller and some glue or bonding agent that will go down first to stick the loop cable to the floor. But in this case, it's quite a clean floor, so we don't need to do that. We're just going to lay the copper straight out on top of the floor. We need to identify our starting position, which is usually 1 meter in and out from the corner where you want to start. We then run the first run of cable, which is called the baseline. That's laid along the long side of the room as we see here. We then show a 2 meter wide section of loop, which is this first rectangle. Next we've got 3.2 meter spacings, which is where the next 2 meter rectangle starts. And then a third rectangle of 2 meters, which is again 3.2 meters away from the previous one. Now the second loop is laid out in exactly the same pattern, but it's offset by half of the distance between them. So the second loop starts at 1.6 and then it's 2 meters and a 3.2 meter gap to the next 2 meter loop. What's interesting is in this simplified low spill array, the pattern doesn't change even when dealing with larger areas. So you could have 6 greens and 5 reds. It depends on the size of the room that you're covering. If we were to transfer this into a sports hall, for example, this 2 meter section might be 5 meters, which is the largest rectangle we'll use on a steel reinforced floor. So you could have a 5 meter rectangle with an 8 meter spacing between them and then an offset of 4 meters, which is obviously half of the 8 meter reading. It is possible to add a smaller 1 meter loop at the end to create a very low spill system if, for example, you have classrooms very close to the wall. And now we're going to test the system. Okay, so now we've set up the loop according to the British standard. The very last thing we need to do is to make sure that the sound that's coming from it is acceptable to the hearing aid users. So I like to do a loop listener test where I switch onto the loop listener section on here, I put the headphones on and I walk around the loop just to make sure that everything's sounding okay. Okay, now we're taking a frequency response, 100 Hertz, 1 kilohertz and 5 kilohertz. And I've taken a sample here. We're at -5, -4, -3. What we're looking for is a variation of about 3 dB. So you can see that we're within that now. So that would be a pass according to the British standard.